All right, we're going to take a look at what we're doing to solve for r. We have an ordered pair 3r and -2, -5. The slope is 2/3. So what we need to do is use the slope formula. Okay? You've got to carefully plug in what you know. Anthony, what's in this whole bunch of stuff? Which number is m? 2/3, because you knew that m stands for slope. So we plug in 2/3 right here. Okay, so 2/3 is m, and then we have to figure out the other pieces. Notice we have pre-marked in here x1, y1, x2, y2. Remember, you never have an x2. -5. Absolutely. So you go through, you plug in the things that you've just labeled. Yes. -3 turns into a -5. -5 minus r over -5. And then in order to actually solve it, who knows, how do you make that work? Go ahead, Miles. You cross multiply. So this one turns into 3 times -5 minus r. Okay? The only reason we put this step in here like this is so that you don't lose anything. Okay. Josh, I'm going to call on you. If I have -10 on this side, when you distribute, what do you get over here? -15 minus 3r, absolutely. Okay. Then, Terrence, the next step? Add 15. Always to both sides, that's right. 5 is -3r. Nasir, finish it off. Good, so you're dividing by -3. So you get 5 divided by -3, which actually is -5/3. Just for the sake of the way it looks, we never leave the negative in the denominator, but -5/3 is the same as 5 over -3. If you have two fractions, also equal to each other. So the way that looks here, 10 times negative 5 gives you negative 10. And when I cross this way, it's 3 times negative 5 minus r. But it times this whole thing as a group. Okay, it's technically a fraction bar is a grouping symbol. If the slope was a whole number, put it over 1. So if the slope was 5, do 5 over 1. There are other ways that you could do it, but that seems to be the way that students make the least mistakes. Okay, so I'm just trying to help you out with that one. I want the least mistakes. That's my goal. So you guys do the best you can and make the least mistakes. And I think everybody has that same goal. Right? Okay, so that's that one. What else do we need to go back to? I do a little bit slower. The one after that. Standard form. Standard form or slope-intercept form? Standard form was the one with 4 examples. That's the one we need to look at. This one? Right in standard form. So let's make this so we can do it one step at a time. So I'm going to erase some of it so you don't have to see the whole thing all at once, so that we can figure out where all these things came from. Okay, so we'll take a look at that. So if we start with this one, we're needing to do that. We're trying to get the x and the y part on the same side of the equation. Add 3x so that you get the x and the y part on the same piece of the equation. So we'll do plus 3x cancel, and we have just 3x plus y equals 4. That is the final answer. We have to make sure it fits the form. You guys told me earlier, the first one has to be a whole number. This 3 is a whole number. The second one has to be an integer. What number is b in this part? 1. Is 1 an integer? Yes. And c has to be an integer. And it is. Because all whole numbers are integers. So this one is done. That's the final answer. Okay. Let's go back a little bit slower. Take a look at this one. So I know it's just a matter of you see too much. Sometimes your brain isn't processing it the way it needs to. So here we go. So I have a fraction sign. Let's see how these fractions and our final answer. So we want to get rid of the fractions. One way to make sure that you get rid of all the fractions is to find something to multiply both sides by in order to make those fractions disappear. An easy little trick for that is to take the denominators that you have and multiply them together. Take the denominators that you have and multiply them together. And that'll give you a nice number to multiply by both sides. Now, if there's just one fraction, we don't have to multiply this, take the denominator and multiply it by both sides. So then what number am I multiplying then? 6. So I'm going to do 6 times this. Then I'm going to do 6 times this, because I'm distributing it. And then 6 times the other side. Okay, so I went ahead and distributed that 6. Because I had to multiply both sides by 6, which means everything has to get that. And when it's broken apart like this, you're going to be able to see the cancellation steps. I want you to be able to see them. All right, so right here, take another color. If I cancel the 6 and the 2, what do I get? 3. Great. Yes, we have to do something about that. While I plug this thing in, you're going to think about what we have to do. Okay, there we go. All right, so what is it, Morgan, that you wanted to do to that? Subtract 4x minus 4x. So this is negative 4x plus 5y equals 2. Question, Miles, or answer? Scratching. Okay. But since you're thinking anyway, what's wrong with this? Why isn't it done? There's a negative 4. So do you know how to get rid of that? Perfect. You're going to multiply everything by negative 1. So I'll go ahead and give that another color so that we can see it and it won't get... So this is times negative 1. This is times negative 1. And so this negative times negative makes positive. So this turns this into what, Ludwig? What's this part? Negative 1 times negative 4. 4. So this is 4x. And then this turns, is the answer positive or negative? It's negative because this is negative times positive is negative. And then the final part is negative 2. Okay. So that's how that goes. Joshua, question? Oh, okay. Yes. Back to the graph one. Yeah, I know that's a graph one. I'm going to do a different graph one because I'd rather do one. That one was number 5 in your homework. It won't necessarily show up on this quiz. It might on the test. But I want to do one that might be more likely to be on your quiz tomorrow. Okay? Yes? Uh-huh. Multiply the denominators. And if there's only one denominator, you have no multiplying to do. You just pick that number. Okay? All right, let's get another one. Miles? So that's a good thing to just kind of remember from your notes is that anything that's a f of x or whatever can be replaced by a y. All right, let's get a new one. I want to get a graph up here. There it comes. All right, and we're going to do a graph. Now there's a couple different types of things you could graph. So we'll do a couple on the same graph. We're going to graph 2x plus 5y equals 10. Okay, now we had a couple of different ways to do it. If I were you, I would graph this one using the x and y intercept method. Who remembers what the x and y intercept method is? Yes. That's the one where you make a little table and you start with x being how much? 0. So 2 times 0 plus 5y equals 10. So if we solve this down, we'd get 5y equals 10. So y equals how much? So y equals 2. And then you would pick y equals 0. And we plug that into x plus 5 times 0 equals 10. And so I would just say 2x equals 10. So how much would x equal? X will equal 5. All right, so we have those, and then you would make a graph. So I'm just going to do a quick one right here. And then this way. Now, my question is, when I graph these, we're using the x and y intercept method. So where does this 2 go? Does it go over here on the x-axis or up here on the y-axis? This one goes on the y. You can tell it's 0, 2, so that's the ordered pair that goes there. So the 5 must go on the x-axis. And then once you have that, you can go ahead and sketch your line that goes through them. Okay, so we're just going to put that in here like that. So you would sketch your line in. So that's one way of graphing. It's the x and y intercept method. The other way that you have of graphing, especially if you have something that's in slope-intercept form, probably that would be less convenient to do x and y intercept method. What would be the best way to graph that one? Yes.
Choosing the
Good. Y-intercept and slope. So the y-intercept is what number?
-4.
So -4, we put that on the y-axis because that's the y-intercept. And then what do you do with the 2/3, Terrence? Up 2 over 3. We can go down and left. We can do another up 2 over 3. Now this one's convenient because it would have shown up right on, it would have a convenient x-intercept, but sometimes they're fractions, so it's just easier to do that way. Yes, Desiree. Let's see, did I put any of these up here already? Linear or not linear? No, I didn't do function or not function. Let me get some, just real quick. Real quick, if this is an x and y axis, and I have something like that, is that one going to be a function or not a function? It's a function because all of the vertical lines will hit only one point. Huh? All the vertical lines you could possibly draw would hit only one point. So it's a function. What if I said draw a square on the graph? So the thing is a square. Okay. Good. A square is not a function. And if you needed to make yourself a little sketch of that, you can do it. So you would make yourself a sketch. And we could draw ourselves a quick little square here. That's a horrible square. But it does hit in 2 points if you try that. All right?